Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is matrices, what you're going to learn today is how to add and how to subtract the two matrices. So let's begin. After completing the very lesson today, my dear student, will be able to add and you also be able to subtract the two matrices. This is what I hope you'll be able to do after completing the very lesson today. So as usual in your favorite segment of the lesson, Marcy's Fun, today, my dear student, I will give you another special group of numbers, and this group of numbers are called honest numbers. So among numbers that are honest, there are numbers that are not honest. So we are going to give you examples of these honest numbers and explain what are they after completing my lesson today, so don't go away. To begin the lesson, my dear student, let us learn the rule. It is this rule that will be our guide in attempting to do addition and the subtraction of two matrices. So let us learn the rule. Before you add or before you subtract the two matrices, those two matrices is the condition for addition and subtraction of two matrices. The condition is that those two matrices must have the same dimension. So if you check the dimensions of the two matrices is the same, then you can add them. Similarly, you can subtract them. But if the dimension of those two matrices are not the same, which means the addition and subtraction cannot be performed on those two matrices. So if the two matrices have same dimension and you want to add them or you want to subtract them, what the rule tells us to do, that is how we add or how we subtract. It says you add the corresponding entries or you subtract the corresponding entries. This is how we now perform addition and subtraction. The very first one is just the condition to test whether you can add or not, or you can subtract or not. But if you can add or you can subtract, but how you add is now by adding the corresponding entries, and how you subtract is also subtracting the corresponding entries. The corresponding entries simply refers to entries in the same positions in the two matrices. Let's just move and take examples. Example number 1, it says let the matrix A has these elements 2 minus 3 in the first row, minus 1 and 4 in the second row, and another matrix called B with 1 and 3 in the first row, 4 and 0 in the second row. And the question asked is to find A plus B. That is matrix A plus matrix B. Solution to this very problem. What we do first is to copy down the two matrices, that is A and B matrix. So let me just write them down. I'm going to add this matrix and this matrix. So based on the rule, what we do first is to check those two matrices before we even attempt to add them. Do they have same dimension? The dimension of matrix A is 2 by 2. It having the 2 rows and the 2 columns. Similarly, matrix B is another 2 by 2 matrix, so the dimension is the same, which means I can add them. So to add now, I'm to take the second rule. It says add the corresponding entries. So if I'm going to add these two matrices, I'm going to have another new matrix, and that new matrix, their entries would now be, that is element in the first row, first column in this result is now going to be 2 plus this one. The corresponding entries 2 in the first row, first column of your first matrix. First row, first column of your second matrix, you add 2 and this one. That will give you the element in your resulting matrix. So I'm going to add 2 and 1. This 2 and this one to get the element here. I'll continue. The element here will now be this element plus this element. This minus 3 in the first matrix plus this 3 in the second matrix is to give you the entry here. I'll continue. So next, moving to the second row, this plus this will give you the entry here. So minus 1 plus 4. And the last will be 4 plus 0, because the rule says we are to add the corresponding entries, that is entries in the corresponding positions in the two matrices. So I'm going to simplify this. So I'm going to have my matrix 2 plus 1, that will give me 3. Look at it. Minus 3 plus 3, that will give me 0 here. Look at it. Minus 1 plus 4, that will give me positive 3 here, and 4 plus 0, that will give me 4 here. So this is now the matrix A plus B. Let me move and take another example. Example number 2, it says let n be a matrix and it has 2, 5 in the first row, 3, 0 in the second row, 1 and minus 1 in the third row, and another matrix M having minus 2 and minus 3 in the first row, 4, 7 in the second, 6, minus 8 in the third row. The question asked is to find n minus M. That is matrix n minus matrix M. Solution to this very problem: copying the given text, that is n minus M, and substituting those matrices, that is one for n and the other one for M. This is the matrix n minus the matrix M. So the rule says first check the condition. Do they have same dimension? Matrix n has 3 rows, 2 columns, so it is 3 by 2. And matrix M also has 1, 2, 3 rows and 2 columns. So the dimension is the same, which means I can do the subtraction. And the rule says to do this subtraction, you now subtract the corresponding entries. That is entries in same position from the two matrices. So let me do that. So I'm going to have my matrix, and in this matrix, I'm going to say the 2 minus the 2. So I'm going to have 2 minus. So that will give me the entry at exactly this first row, first column. I'll continue. So to get the first row, second column, we'll now have 5 minus 3. So I'm going to have these are the corresponding entries, 5 and minus 3, and I'm subtracting them. So I'll continue. Second row will now be 3 minus 4, 3 minus this 4. So I'm going to have 3 minus 4. Now second row, second column will be 0 minus 7. 0 and 7 are in corresponding position, so I'm going to subtract them. 0 minus 7. Next, I'll move to the third row. I have 1 and this 6 in corresponding position, so I'm going to have 1 minus 6, and the last minus 1 minus 8. There I'm going to have this. So I'm going to do the subtractions each and write the result here. So 2 minus we will now change it to 2 plus 2, and that will give me 4. 5 minus 3, that will now be 5 plus 3, and that will give me 8. 3 minus 4, that will be minus 1. 0 minus 7, that will be minus 7. 1 minus 6, that will be minus 5. Look at it. And the last minus 1 minus 8. The minus will change it to plus. So I have minus 1 plus 8. That will give me positive 7. So this is the matrix n minus M. I continue. Let's take another example. Example number 3 says simplify this task. I have 3 matrices. The first matrix minus the second matrix and plus the third matrix. This is what I'm asked to do. So solution to this very problem, what I'm going to do, copying the given task, that is the 3 matrices. This first minus the second, then plus the third. So I can do this addition and the subtraction all at the same time. So let me do that. So to do this, I'll also check the corresponding entries. So I'm going to have my matrix. I want to do it all at once. So I'm going to now set 1 minus the corresponding entry minus 5, and then plus the corresponding entry 2. So this entry 1 minus 5 and 2 are now in corresponding positions. So I can now set 1 minus 5, then plus 2. Let me do that. So I'm going to have 1 minus 5, then plus 2. I'll continue. So I'll move to the second, that is element in the first row, second column. So the 4 here, look at this 4, and this 2, and this 3 are in corresponding position. So I can now say 4 minus 2, then plus 3. Let me write it here. So 4 minus 2 plus 3. I'll continue. I'll move to the second row. So 3 and this 3 and this minus 4 are in corresponding position. So I can now say 3 minus 3, then plus minus 4. Let me write it here. So 3 minus 3, then plus minus 4. I'll move here. The element will be here, will now be those 6, 5, and minus 8, then corresponding. So 6 minus 5, then plus minus 8 is what I'm going to have over here. So 6 minus 5 plus minus 8. I'll move to the last row. 2, this minus 2, 12, and 2 are in corresponding positions. So I'm going to have minus 2 minus 12, then plus 2. Let me write it here. Minus 2 minus 12, then plus 2. And the last one, 3 and 0 are in corresponding positions. So I'm going to have 1 minus 3, then plus 0. So I'm going to simplify this. That is to perform this addition and subtraction. So I'm going to have my matrix like this, where I'm going to write the final results here. So this 1 minus minus 5 will now change it to 1 plus 5, then plus 2. That will give me answer 8. Then coming to this very one, 4 minus 2, then plus 3. 4 minus 2 is 2, 2 plus 3, that will be 5. So I'm going to write 5 here. Then here, 3 minus 3 will be 0. And plus minus is minus, so I'm going to have minus 4 here. And 6 minus 5, that will be positive 1. And positive 1, this plus minus is minus 1 minus 8, that will be minus 7. Let me write it here. Then the last row, minus 2 minus 12, that will be minus 14. And minus 14 plus 2, that will give a result minus 12. And the last one, minus 3 plus 0. If done correctly, you now have minus 2. This would now be the result of subtracting this matrix and adding it to this. So let me just take one more example. Example number 4, it says find the value of x, y, and z if you have this 3 matrices, that is this matrix plus this one, which is now equals to this very matrix. So it's just like you have equations involving matrix in which some of the entries are your unknowns, x, y, and z. Solution to this very problem, what we simply do, copy this given equation, which is in form of matrix. So I'm going to have these 3 matrices. That is the first matrix plus the second equals to the third matrix. So this is equation involving matrices. In this, some of the entries will now be these unknowns x, y, and z. So let me just find them. This is one of the unknown in the first matrix, y. This is another unknown in the second matrix, z, and this is another unknown, x, in the first matrix. So what you simply do, you don't have to waste the time. The addition of these 2 matrices is what gives you this matrix. What we simply do, just check those unknowns, their corresponding entries, and add them and equate to the corresponding entries. What I'm trying to say is just find out those unknowns. If I start with the unknown z, for example, this unknown z and 1 and 8 are now in corresponding positions, which means it is 1 plus z that gives you this 8, because the addition of the 2 matrices gives you this matrix. And remember, we add the corresponding entries to get the entry in your resulting matrix in that very corresponding positions. So 1 plus z is what gives you this 8. So you can now have a simple equations, 1 plus z equals to 8, which you can solve for z exactly by taking 1 to the right hand side. There you have z to be equals to 7. So I can move to the next unknown. My next unknown I can see is y. Look at y here. I will now mark the corresponding entries of this very unknown element y. The corresponding is 4 here, and the corresponding in the resulting matrix is this minus 1. So which means y plus 4 is what gives this answer minus 1 in the sum of those matrices. So I can now form also simple equation, that is y plus 4, because we are adding the 2 matrices to get this matrix. So y plus 4 will give me the element in the corresponding positions, which is minus 1. So I can now take this 4 to the right hand side where it will change to minus. So combine with minus, so you now have y to be equals to minus 5. Let me take the last unknown. The last unknown is x. X is in this position and their corresponding positions is this element 1 and this element 4. So it is x plus this one that gives this result 4. Let me form simple equation. X plus y equals to 4. Taking 1 to the right hand side where it will change it to minus. So you now have 4 minus 1 and you now have finally x equals to 3. This is how we now solve these very equations. That is equation involving these matrices. How we can now find the value of those unknowns. So with this, my dear student, I have come to the end of this very lesson. I hope you find it resourceable. Let me just move to the last segment, Maths Expand, and explain what numbers that are called honest numbers. A number n is honest if what happened if that number can be described exactly using n letters. That is, if you are to describe that very number in words, you can use exactly n letters in the words. Let's just take examples. Examples for 8 and 11, all these are honest numbers because the number 4 can be written F-O-U-R in words. So I used exactly 1, 2, 3, 4 letters, which the number of letters used here is exactly the same with the number itself. So 4 is honest because it can be described in words using exactly equal number of letters as the number itself, that is 4 letters. Let me take 8. 8 is another honest number because this 8 can be described in words as 2 cubed. 2 cubed. If you count how many letters that they are used, 1, 2, 3, 4, 5, 6, 7, 8, exactly 8 letters as the number itself. So 8 is another honest number. Another honest number is 11. 11 can be described in words as 2 plus 9. If you count the number of letters that there, they will give you exactly 11. So 11 is another honest number. Other examples of honest number, you have here 10, 13, 19, all these are honest plus many more. And we see more examples of this special group of numbers in our subsequent lesson. Thank you for your attention.